Welcome to today's ArXiv CS Digest for March 24th, 2026. We received 718 new computer science papers today across 55 subfields. Let's dive into the top picks. Trend 1 of 5, Generative AI for Dynamic Vision. This trend leverages generative AI to understand, model, and synthesize dynamic visual information for complex, evolving real-world scenarios. This cluster covers 226 papers. Representative work includes OCCNE, Generalized Unconstrained Urban 3D Occupancy, UniGRPO, Unified Policy Optimization for Reasoning-Driven Visual Generation, and DA Flow, Degradation-Aware Optical Flow Estimation with Diffusion Models. Trend 2 of 5, Computational Methods for Complex Systems. This trend unifies research applying advanced computational and AI methods to model, analyze, and control diverse complex systems across scientific and engineering domains. This cluster covers 135 papers. Representative work includes estimating flow velocity and vehicle angle of attack from non-invasive piezoelectric structural measurements using deep learning, from product Hilbert spaces to the generalized Koopman operator and the nonlinear fundamental lemma, and paired Wasserstein autoencoders for conditional sampling. Trend 3 of 5, Advanced Systems, Security, and Robotics. This trend unifies research on designing, securing, and optimizing advanced systems, including robotics, quantum computing, and resilient distributed networks. This cluster covers 97 papers. Representative work includes dynamic light spanners in doubling metrics, design, mapping, and contact anticipation with 3D, printed whole-body tactile and proximity sensors, and stablecoins as dry powder. A copula-based risk analysis of cryptocurrency markets. Trend 4 of 5, AI agents and software and security. Research explores employing AI agents to automate and strengthen software engineering processes and cybersecurity defenses. This cluster covers 129 papers. Representative work includes REQ Fusion, a multi-provider framework for automated PEGs analysis across software domains, regulating AI agents, and CSDS, a canonical security telemetry substrate for AI-native cyber detection. Trend 5 of 5, Analyzing and Applying Large Language Models. Understanding LLM capabilities, limitations, and biases alongside their practical application and evaluation across diverse domains. This cluster covers 131 papers. Representative work includes MedObvious, exposing the medical Moravec's paradox in VLMs via clinical triage, collaborative evaluation of deepfake text with deliberation-enhancing dialogue systems, and failure of contextual invariance in gender inference with large language models. Up next, our first paper out of 5, Counterfactual Identifiability via Dynamic Optimal Transport by Fabio de Souza Ribeiro and Ben Glocker from Imperial College London, UK. Let's break down its key contributions. This contribution establishes a new foundation for identifying high-dimensional multivariate counterfactuals using continuous time flows. It extends to non-Markovian settings, addressing a critical gap in existing counterfactual inference methods by ensuring identifiability. The paper characterizes specific conditions under which flow matching, leveraging dynamic optimal transport, generates a unique, monotone, and rank-preserving counterfactual transport map. This ensures consistent and causally valid inference for counterfactual queries. Up next, our second paper out of 5, BuilderBench, The Building Blocks of Intelligent Agents by Raj Gugger and Benjamin Eisenbach from Princeton University. Let's break down its key contributions. Introduces BuilderBench, a novel benchmark designed to accelerate research in agent pre-training through open-ended exploration. It challenges agents to learn general principles by interacting with physical blocks and building structures. Features a hardware-accelerated simulator, enabling robotic agents to interact efficiently with various physical blocks. This provides a realistic and scalable environment for agents to experiment and acquire building skills. Includes a comprehensive task suite comprising over 50 diverse target structures. These tasks are carefully curated to rigorously test agents' understanding of physics, mathematics, and long-horizon planning capabilities. Proposes a training wheels protocol to facilitate initial agent development. This protocol allows agents to be trained and evaluated on building a single target structure, simplifying the learning process. provides single-file implementations of 6 different algorithms as valuable reference points for researchers. This resource helps jumpstart new research and offers baselines for comparison within a benchmark. Up next, our third paper out of 5, TRAP, Hijacking VLA Code to Reasoning via Adversarial Patches by Zhengxian Huang and Wenyuan Su from Zhejiang University. Let's break down its key contributions. The paper empirically demonstrates that chain of thought, COT, reasoning strongly dictates action generation in VLA models, even when semantically misaligned with user instructions. This observation forms the basis for the proposed attack. Introduction of TRAP, the first targeted adversarial attack framework specifically designed for COT reasoning VLA models. TRAP aims to hijack control by manipulating the intermediate reasoning process. TRAP employs an adversarial patch, such as a physical coaster, to subtly corrupt the intermediate chain of thought reasoning. This patch acts as the novel attack vector to influence VLA behavior. The framework optimizes a specialized COT adversarial loss function to precisely induce specific and adversary-defined behaviors. This ensures the attack effectively hijacks the VLA's output as intended. The paper validates TRAP's practical feasibility by implementing the adversarial patch in a real-world setting, printing it on paper. This demonstrates the tangible threat to VLA systems. Up next, our fourth paper out of 5. When AI shows its work, is it actually working? Step-level evaluation reveals frontier language models frequently bypass their own reasoning by Abhinaba Basu and Pavan Chakraborty from Indian Institute of Information Technology, Allahabad, ITA. Let's break down its key contributions. This novel evaluation method assesses if language models genuinely use their step-by-step reasoning. It removes one reasoning sentence at a time, checking if the final answer changes. This simple, API-based test reveals reasoning faithfulness. This analysis delves into open-weight models using logit lens and attention patterns. It provides internal evidence, like COT attention drops in late layers, to corroborate behavioral findings on reasoning faithfulness. Up next, our fifth paper out of 5, Calavi, Predicting When Independent Specialist Fusion Works, a quantitative model for post-hoc cooperative LLM training by Ramchan Kumarishan from Uri Labs. Let's break down its key contributions. Contributors independently fine-tune copies of a shared base checkpoint on their own domain-specific data. This foundational step creates diverse specialists from a common origin, which is essential for effective post-hoc fusion. After independent training, the specialists are fused using a lightweight mixture of experts, routing mechanism, trained in only 500 gradient steps. This learned routing assigns tasks to the most appropriate specialist, achieving Oracle optimal assignment. A quantitative model is provided to predict the performance gain from specialist fusion based on their divergence from the shared base checkpoint. This enables practitioners to estimate the cooperative value before committing significant computational resources.